Hello and welcome to the Green Business Podcast, where we meet exciting climate entrepreneurs. My name is Bharti. Today with me is Dr. Srikanth Sola, co-founder of Devik Earth, which offers exciting solutions to handle air pollution. Srikanth is a cardiologist and he likes MRI machines very much. So he thought of using similar technology to capture and contain air pollution. It's going to be an exciting show. Hi, Srikanth. Welcome to the show.
Hi, Bharati. It's a pleasure to be here.
Yeah, lovely. I want to start with how you founded Devik Earth, and please also talk about why you like MRI machines so much.
Sure. It was a long journey. I was doing very well. I'm a US trained cardiologist, grew up in the United States. And, most Indians who go abroad, they tend to stay there. We had gone long ago and we stayed there also, but I decided I wanted to come back and serve my country. So in 2008, I left the United States to come back to India to serve. And I joined the Sathya Sai Hospital, the super specialty hospital here in Bangalore, where I live. And I was fresh off the boat, freshly minted cardiologist from the United States. I had worked at great institutions like Cleveland Clinic, graduate of Stanford, Duke universities, had done very well, had worked a lot with big time companies like GE Healthcare, Siemens, Philips Medical, inventing lots and lots of new technologies. But still, my heart was always in India, and not just samosas and pakoras, but being with the people and really making a difference. And I remember in my first week, just a few days after joining, I had a young fellow who was 28 years of age, and he had a heart attack from air pollution. He was a shoe cobbler. The fellows who repair sandals and shoes on the side of the road. He's breathing in vehicle fumes all day long as part of where he stays for his work. And he had a heart attack. And, at that time, this was 2008, we didn't know so much about the heavy impacts that air pollution has on health. I mean, we knew 7 million people die every year due to the effects of air pollution, but it wasn't until years later that we understood that 1 in 3 heart attacks and something like 1 in 4 strokes are caused by air pollution. We know that people in India lose on average 6 to 9 years of life due to the effects of air pollution. I just knew this patient had a heart attack. He needed an emergency angioplasty operation to open the blockage that caused his heart attack. We did it. He recovered so well that a couple of days later, he walked home. That was like, cool. This is exactly why I came here. I gave myself a pat on the back. But then 2 days later, the same thing happened. It was a young fellow, 32 years of age, a taxi driver, driving, in Bangalore through the street, breathing vehicle fumes all day long. He also had a heart attack. We also did an emergency angioplasty operation, but he died right on the table, right in front of me. And despite everything we did, we couldn't resuscitate him. And afterwards, I had to go back and explain to his wife, who actually now his widow, and they had a small daughter, and his 2 parents were there. And I said, I'm sorry, we did everything we could, but we could not save him. And this really got me to thinking. It was my patients that started all this. Air pollution affects everyone, rich or poor, whatever part of the world you live in. 99% of the world's population breathes air that's actually unfit to breathe, according to the World Health Organization. It's not just Delhi, it's everywhere that you live, people all over the world. And I thought, well, shoot, as a cardiologist, there's only so many angioplasty operations that I could do per day, right? I mean, it's a drop in the bucket. Let me see if I can develop a technology that will help to clean the air at scale. And so what we did is we tried everything. We tried, high-end air purifiers. We tried fancy ionizers, and none of them worked at scale. They would clean a small area, but when you're trying to clean outdoor air, the air is always moving because of wind. And you're bringing polluted air into the clean air. And if you're a fan or a filter, it just doesn't make sense outdoors. It's good for indoor spaces like an office or home, but not for outdoor spaces. Now, because I'm a cardiologist who specializes in scans of the heart. In fact, I do a lot of MRI scans of the heart. And how does MRI work? We use pulsed radio waves to affect the body in different ways to create those lovely images that doctors use to figure out what's happening with the patient. It's also used since about 1996 to treat different types of cancers and also electrical problems in the heart. As a cardiologist, I use this pulsed radio waves all the time to treat electrical problems in the heart. It's routine and it's quite safe to use. So then it occurred to me that actually radio waves are really one of the few things that can travel across a distance. And to make a long story short, from 2008 to 2018, we did a lot of work. We developed this great technology. We licensed it, we patented it, and then 2018, David Earth, our company which brings clean air to the public, was formed.
Right, right. And okay, MRI tech in some way helps fight pollution, right? But what exactly does it do?
It's the basis. It's the basis of this. See, actually, pulsed radio waves is an old technology. What David Kirk has done is it's created a pulsed radio wave platform for air pollution, water pollution, and now carbon capture. That's what we're doing. And what happened is in 1971, the first technology using pulsed radio waves was actually brought out for water pollution. So actually using pulsed radio waves as an old thing for pollution, and it was used as pulsed radio waves for water pollution was very useful for removing certain types of pollutants from what's called effluent treatment plants from industries, the polluted water that comes from industry was quite good. And then later in the 1980s, newer technologies that were more cost effective came along and the pulsed radio wave energy went away. But if you talk to retired environmental engineers from that time, the 70s and 80s, especially those who worked in sewage treatment plants or effluent treatment plants, they'll say, oh yeah, pulsed radio waves, I remember that. It was a very good technology, especially for certain uses. Then in 1976, pulsed radio waves came along for MRI, and then in 1996, pulsed radio waves came along for treating cancers, tumors, heart problems, and so forth. And then in 2008 or 9, we figured out how to use it for air pollution, and it's just been, a zoom journey since then.
Lovely. But MRI, so these are MRI rays, right? So when we go to those rooms,
it's radio waves. It's actually it's radio waves. It's actually Wi-Fi is what we use. And the reason we use pulsed Wi-Fi is, number one, Wi-Fi is safe to use according to the World Health Organization. There's no effect on humans or the environment. Number two, the Wi-Fi frequency is a uniform frequency across the world. Air pollution affects everybody. No, it's not just people in India. It's people in Chile, it's people in China, it's people in London. Everywhere you go, air pollution is a problem. And so Wi-Fi frequency is the same throughout the world. It's safe to use and it's easy to use because the hardware and technologies have already been worked out. We're not interested in reinventing the wheel. We'd rather make a smarter wheel that can be used to solve different types of problems.
No, but when we are going to X-ray rooms or MRI rooms, not that I want to go there, but they, we are supposed to stay for 5 minutes and come out as soon as possible because they tell us that these
nothing like that. Nothing like that. MRI scans are quite safe. Yeah, MRI scans are quite safe. We're able to use them in pregnant women all the time. The reason in an MRI scanner is the MRI scanner has a strong magnet. Our technology doesn't use anything like that. It's just the principle of using pulsed radio waves is what is common. And it's these pulsed radio waves that are present throughout. Now, it's different from a Wi-Fi router that we use all the time. A Wi-Fi router is also working the Wi-Fi frequency, but it's used for data transmission, and those waves are transmitted in continuous. In our technology, it's a pulsed manner, and it's how it's pulsed that creates the special effect. Basically, what happens is you pulse radio waves, you create a very weak electromagnetic field, small particle pollutants that under normal circumstances, what happens, these small microscopic pollutant particles are floating around in the air. And because of their natural positive and negative charges, like a magnetic charge, not like an ionization charge, but positive and negative frequencies, like magnetic forces, they collide with each other, and now they're larger in size, and then they settle to the ground. And this process happens all the time. Scientists call it dry deposition. And it's how nature removes about 60 to 70%, about two-thirds, you could say, of all PM10 and 2.5, the worst of the particle pollutants from the air. What we do with our pulse radio wave technology, it's called Pure Skies, is we create a weak electromagnetic field. The magnetic forces are made a little bit stronger, and so this coagulation and settling is sped up about 6 to 7 times faster compared to what nature would do. So that means if it takes nature about 6 or 7 hours to clean a certain amount of air, we can do the same thing in just 1 hour.
Okay. So, Doc, let me summarize it. So, dust particles are there or pollutants are there in the air all the time. Your technology charges them, positive, negative charge. They attract each other and they become bigger and start falling. Right?
Sort of, except like
Yeah.
when we talk about charges, that's what an older technology called ionization does. So ESPs, electrostatic precipitors, do that, and they work fine. Ionization doesn't work very well for outdoor spaces because the ions only go so far before they get dissipated in the atmosphere. And secondly, ionization creates a harmful gases like ozone, which are not helpful, actually dangerous when we breathe them in. What we do is we change the magnetic charge. It's called a dipole, D-I-P-O-L-E. We create a temporary dipole on these particles, and that's the effect that we have. There's no magnetization, ionization.
And this frequency is must be lower or different than what we have in the MRI rooms in the hospitals, right?
Yeah, the resemblance is not so much to the MRI. The resemblance is that MRI scanners, radio frequency ablation of the heart or for certain tumors, they all use radio energy, but they're used in a pulsed manner. And that's the secret thing, is that the radio waves are pulsed. Why? Because that creates certain effects that when we control it in certain manners, can be used beneficially without causing harm. That's what we do with the Pure Skies technology, is we pulse radio waves to speed up how nature is doing this. Now, we've studied this to make sure that it's safe. And the technology, anything that uses Wi-Fi energy is well regulated by international standards. And obviously, we make sure that our technology meets those standards.
Right. And what was the process of prototyping like? Let me just put an image of your product here. Tell us how you got here from the day you thought of using.
Yeah, so the unit that you see there is our Pure Skies 2.0 unit. It's about 8 kilograms, and it's the size of a small microwave oven. The first generation units, what we had even before we launched commercially, they were the size of maybe 2 washing machines stuck together, and they weighed about 200 kilograms, 200 kgs. Now we're down to 8 kgs, and we're already on the Pure Skies 3.0, which is a small unit. It's meant to be the size of a car keychain. You know what you use to open and close your doors? At your car, when you press the button to open, unlock, and lock your car doors, it's that size. That covers 8 to 10 meter radius. These big machines, the industrial grade machines that you see here, those cover about 250 to 500 meter radius. So about almost up to 1 kilometer diameter when they're placed outdoors according to line of sight. We can then place many of these units across a particular area to cover literally hundreds of acres. And they're quite effective when they're placed together. It's linking them together, creating a network, just like how Wi-Fi routers might be linked across a large space to create telecommunications coverage. We do the same thing, but in this case, it's to clean the air.
Right. And it took you about 8 to 10 years to come here. What was the longest figuring out the pulse wave technology, or getting the form factor right, or maybe there are things that I
No, the longest thing was that I was a full-time cardiologist seeing patients 6 days a week. And I had to do this research either before 8 o'clock or after 5 p.m. That was the longest thing. Effectiveness with this. And we actually got data showing us that when we put this in the hospital and looked at people living in the area where the air was cleaner around the hospital, we saw that the number of heart attacks went down by 30%, number of respiratory infections went down by 25%, number of strokes went down by 40%. And I thought, man, there's nothing I can do as a cardiologist that has such a huge impact on public health. as just
Right.
providing clean air.
Okay.
And that was the impetus to get Data Growth started.
Okay. And as your technology advanced, the size of the equipment became smaller and smaller. That's
Smaller
what
and
happened.
smaller, and we're looking to and stronger, more efficacious. It works faster. Each unit, we take advantage of all the latest technologies, whether it's IoT to artificial intelligence to microcontrollers to the latest hardware advancements. We're able to do that. Being in Bangalore and having an R&D center in Hyderabad allows us to really work with really amazing minds to keep advancing technology on a regular basis.
Okay. And how does this work? So you put it along a pole in an open area and then it covers certain.
Yes, exactly. So it's just like if you think remember the last time you went to an airport, maybe you glanced up at the ceiling and you would see small Wi-Fi routers on the ceiling of the airport. And so these Wi-Fi routers are placed throughout the terminal so that there's Wi-Fi coverage throughout the entire building. The same thing is true, except we're doing this to provide clean air for outdoors. What types of places? We work primarily in industries where particle pollutants like PM10 and PM2.5 are problematic. So that would be industries like steel, thermal power plants, mines, specialty chemicals, airports, for example, on the passenger side. This is where we work, primarily in outdoor areas of heavily polluted sites, cities as well. And so then we place these strategically, either on poles or on top of building rooftops. Everything is powered by solar. All the units talk to each other. We talk to all the units. We monitor everything. And the air quality is measured by an independent company. And the report of the improvement in air quality is given by that company to the customer.
Okay, so this assurance you have to keep providing every now and then, this third party.
Because most air pollution is invisible, right?
Very small.
Unless it's really polluted, like in Delhi on the smoggy days in the winter time we see, or in Mumbai now almost all the time Mumbai is polluted, unfortunately. But generally most pollutants are invisible, so you have to measure them using specialized machines. Now we're in the business of reducing pollution, but we're not in the business of monitoring pollution. So we have a properly certified environmental engineering company come onto the customer site, do the measurements using the reference grade, the standard, gold standard type of machines, and then they give the recordings or the data directly to the customer. That makes everyone happy and keeps the data very transparent.
Okay, so that's the part of the package. When people buy Pure Skies, one third party performance evaluation product comes with it, right? That's how you say it.
Yes. Generally, what you want to know is, well, how much did air quality get better, right? Because again, we can't see it, right? It's like ultraviolet light. You don't really see UV light or infrared light. But if you use specialized machines, you can certainly measure it. So in the same way, you really can't see microscopic pollutants. They're microscopic. They're below the visible range, but you can certainly measure them. Typically, what we do is we'll take two sites simultaneously, one intervention site where our technology is present, another site which is the control site, which is similar as possible to the intervention site, and then you measure simultaneously. And what happens is that the place where the machine is present, the pollution level goes down, and the place where the machine is not present, pollution levels more or less stay the same.
Okay, and how does it compare with the or more importantly, how do they treat it now before Pure Skies came in? What do people do now? In Delhi, I know they have smoke towers. They used to have smoke towers, but what do industries do now? And then maybe you could talk about how cost, both comparison in terms of both cost and efficacy.
Sure. So if you look at the current standards, the industries will always try to reduce emissions from their chimneys, the stacks, the big chimneys that come out. And they have very well-defined equipment, air pollution control equipment like electrostatic precipitators, baghouse filters, dust cyclones, other types of really big machines that are able to more or less effectively capture a large part of the pollutants so that the air that comes out from the chimneys is much cleaner than what went in. The problem is that just the ordinary day-to-day work also creates a lot of pollution. Let's say you're in a thermal power plant. and you're getting coal from your mine. It comes in on trucks or lorries or trains, and the coal is dumped in a coal yard. It's put onto a conveyor belt and then taken to the crusher, and then from the crusher it's taken to the boiler where it's burned and then used to create energy for turning the turbines. That's how coal thermal power plants work,
Right.
more or less. But just the process of transporting that raw material, dumping it, putting it
Yeah.
onto a conveyor belt, dumping it again, it creates a lot of dust, a
Yeah.
lot of PM10. These are called fugitive emissions, fugitive
Right.
like a bad guy. And
Yeah.
it's these fugitive emissions that are hard to control. Certainly, industries like coal and cement, they'll have technologies in their big machines, their plant,
Yeah.
but it's these fugitive emissions that are very hard to control. In other places like mining, there's nothing, right? They're just digging into the dirt. And as they dig, all sorts of dust comes out, and that goes literally for many, many kilometers. We have a large installation, several installations in Chile in South America, which produces about half the world's copper. And they were having huge problems with dust from their copper mines. After we put in our technology, pollution levels went down by more than a third. And especially for the neighboring cities, this was a huge benefit because they found that the air that they were breathing was much cleaner compared to before.
Right. Right. So what do they? So they use some equipment. There are instruments to control the source lead emissions, but the fugitive emissions is the big problem, which is where Pure Skies
It's a
come
big
in, and
problem.
we don't
It's
have
a big
anything
problem.
else. Yeah, it's a very big problem.
There's
and we
certainly
don't
ways
have.
to reduce it. There's basically, it's called industrial hygiene.
Yeah.
So you put up windscreens, you make sure all your conveyor belts are covered, you may spray water and so forth.
Yeah.
But if you look at these copper mines in Chile, for example, it's in the middle of the Atacama Desert, which is the driest region in the entire world. They don't have water to spray there. In fact, whatever water they use to run their mines is taken from desalination plants literally 200 kilometers away and brought in through pipes to their mines. So they don't have that option. So for them, dust control is a big challenge.
Now we also don't have, so we are in the same boat.
We also don't have water, so it's very precious resource. Yes.
Okay. And how many installations have you had so far? And do people buy this, or is it a service?
At last count, we have some 120, 150 machines, depending on the size and so forth, around the world. And we have two different models. One is a sales model where we sell it like any other piece of equipment, and that's usually preferred by heavy industries and so forth. We also have a subscription or lease model, which is often preferred by smaller companies because it's easier on the pocket. And also, interestingly, in some places like Europe and South America, we find they prefer a subscription because they're just used to it. They're more used to hardware subscriptions as part of their working culture. And that works fine for them. So we're able to provide it in a way that meets the customer's requirements.
And then your product comes with a warranty and maintenance for a few years, right?
Yeah, the machines are quite robust because they're based on the principle of Wi-Fi. If you think about your Wi-Fi router in your home or office, how often do you have to maintain it or repair it? I mean, hardly any, right? It just runs all the time. Our machines are like that also.
Okay, and this data, so one third-party company monitors, but the customer also is able to monitor on their phone or whatever. That comes with.
If they'd like to monitor, many of the big companies will already have their quality monitors in place. We will do some type of quality assurance to make sure that their monitors are actually giving accurate data. And if they are or not, if they're not, we'll help them to make sure they're getting good quality data, and then they can use their own monitors as well.
Okay. And lastly, Doc, what is the biggest challenge of selling something like this, something very new, which has never happened, and people can't even see the results immediately, right?
See, I think that the biggest challenge for us was realizing who should we sell to? Because if you talk about clean air, everybody wants clean air, right? I mean, everybody would like to have it. But the problem is not everybody's willing to pay for it. So identifying those customers who really would require this took us some time. Basically, we're looking at customers where the cost of non-compliance
Hmm.
with environmental norms is very high. And as an example, one of our customers in South America, it's the largest mining company in that particular country, so I won't name the country, but one of their mines was shut down for just 1 week. 1 week because of exceeding air pollution
Yeah.
norms.
Right.
So,
Right.
but every day that they were shut down, they lost $3 million in
Hmm.
operating revenue. So a total of $21 million. But their plant was shut down for a week. So there's an additional cost of restarting their plant and then that ramp up time while their operations returned back to full speed. So it was more than
Hmm.
just that. On top of that, they faced a huge amount of negative publicity and media coverage,
Hmm.
as well as ongoing protests from the neighboring communities. And so for them, the cost of non-compliance with environmental norms is very high. And those are the types of customers that are best
Yeah.
suited for this type of air cleaning technology.
And how long is the sales cycle to get them to, you know, buy
We
it? How
work
long
with
does
the
it?
heavy industries, right? So steel,
Right.
mining, thermal power plants. So it's B2B enterprise selling, which is about 2 quarters.
Okay. And you make this in-house or is it outsourced? How does
We do all the
device?
work ourselves. The PC boards are, of course, outsourced, but everything else is done in-house.
Okay, and you already sold 150 of those, right?
We're doing quite well, and now we just finished a pre-Series A fundraise led by Axelor Ventures here in Bangalore. We're looking forward to growing internationally as well as accelerating our product development line so we can keep bringing new, more innovative products to the public.
Yeah, that's wonderful news, and thank you, Srikanth, for your time today. And lovely.
Thank you, Bharati.
Yeah, yeah, lovely to hope to see you again. Yeah, thanks.
Great. Thank you so much. Thanks.
Yeah.
Bye-bye.
Bye.